So today we're going to continue the discussion that we started yesterday of solving equations, and essentially it's a review of last year. A few things will add a twist here or there. But we're going to solve equations either using multiplication or division. And with any equation, when we have one side, a plus 3 equals 10, if I do one thing to the left side, and I do the exact same thing to the opposite side, I end up with a statement that is still equal, but a lot of times we can isolate a variable and figure out exactly what the variable in that equation equals. But today, instead of using addition and subtraction, we'll use multiplication division. So in this instance, we have t divided by 3 equals 7. I undo division using multiplication. So I'll go ahead and multiply by 3, multiply by 3. If I wanted to write this out, I would have 3t divided by 3 equals 7 times 3 is 21. At that point, I can go ahead and divide 3 by 3 and we get t equals 21. But typically, we just can cancel here and get t equals 21 and do it in a single step rather than writing it all out. In these next two examples, we're going to multiply by a fraction. And I know the one here looks like we are dividing, but we're going to show you how we can do that using a fraction. So, looking at 2 1/4 times g equals 1/2. I'm going to change this into a mixed number, or an improper fraction, pardon me. So 4 times 2 plus 1 is 9/4 times g equals 1/2. Now, any number times its reciprocal is always 1. So in this case, I'm going to go ahead and use the reciprocal of 9/4, which is 4/9. And what I do to one side of the equation, I need to do to the other. At this case, I'd get 36 over 36, which is really just 1g. And that's going to equal 4/18. Okay, typically we don't write the 1 in front, so we're going to have g. And then the 4/18 we need to simplify to 2/9. And our final answer is g equals 2/9. On this other side, if I'm looking to solve it by multiplying by a fraction, the reciprocal of -6 is going to be -1/6. So I'm going to go ahead and multiply both sides by -1/6. And you can get -42 over 6 equals m. When we go ahead and simplify -42 over 6, we get -7 equals m. As always, if I wanted to check that answer, I can go ahead and go back to the original problem, 42 equals -6 times -7, to verify that yes, 42 does equal 42. Okay, again, we don't have to check in our classwork, but on a test it's good to know how to go ahead and check if need be. So, in this case, we have 13 times s equals 195. To undo multiplication, we need to use division. So I can go ahead and divide both sides by 13, and s is going to equal, and we can go ahead and go 195 divided by 13, that's going to be 113. We're going to get 65. That's going to go in there 5 times. So we have s equals 15. And again, I could check my work. In the second example, on the right here, -3x equals 12. That's the same as -3 times x. We undo multiplication with division. And again, going through Dylan and showing our work. -3 divided by -3 is 1. That leaves us 1x, which we write as x equals -4. And again, if we wanted to, we could go -3 times -4 does in fact equal 12, and our answer checks. So, at this point, go ahead and try these 3 problems. If you've got them, feel free to work through quickly, write your answers down, and come back and after you've hit pause, check to see how you did. No, really, hit pause now. So the first example, we need to go ahead and multiply by 2, because that's a reciprocal. We were dividing by 2, we can go ahead and multiply by 2. In the second example, I'd multiply by the reciprocal of 3/5, which is 5/3. And again, any number times its reciprocal is 1, so we have got k on the left side of the equation by itself. And then we go ahead and we get 30 over 3, which will simplify to k equals 10. In the last example, again, 2/3 times b, I'm going to multiply by the reciprocal, so that's 3 over 2. Go ahead and change colors here so it doesn't blend in too much. 3 times 1 is 3, 2 times 4 is 8, the whole fraction is negative, and so b equals -3/8. And using fractions is going to be a little bit new for this year, so stick with it. Again, if you need to, you can pause and rewind, watch the video again to try and make sense of it. If you've got it, go ahead and move forward. Okay, here we're trying to apply what we just learned, taking a real life situation and using math to kind of take a closer look at it. So, on the moon, something weighs about 1/6 as it would on Earth. So we're trying to figure out what was the weight of Neil Armstrong's suit and life support backpacks if he were on Earth. So as we go through the little clip that comes out of the book, we find that his suit and life support backpacks are 33 pounds. Okay, so 1/6 of what he was on Earth equals 33 pounds. At this case, I can go ahead and multiply by 6 over 1, or 6, and we get the weight on Earth. E is this weight of the packs on Earth. So 33 times 6, can go ahead and work that out real quick, 18, and we end up with 198, and again, that should be 198 pounds. So here's today's assignment. It is 15 to 47 odds, and then 49 to 51. Go ahead, work through it. If you get done early, please go back, make sure your study island's done, and take care of any other missing work that you may have before we go on to looking at other options for things to do. Hope the lesson went well. We'll talk to you on Thursday.